Hello again. Let's go. Today I just found out my videos are being kicked off YouTube unless they're under 15 minutes. So good news for you if you're sick of hearing me talk too much. I have to keep everything under 15 minutes. So let's dive in. All right, for the warm-up, go ahead and pause it here. Give it a shot. As always, if this was easy for you, great. If not, we can discuss here in a second. Those are the answers I got. Just briefly, talking about these ones. So here the velocity of 0 is asked what's the velocity at 0. Remember, this is a velocity function here. So the velocity function equals 1 when you plug in 0. Here it's asking for the derivative of the velocity function at 2, or it's asking for the slope at 2. The slope at 2 here, that is the slope of 0. Here, this is asking, this is kind of the displacement, or another way of asking is what's the area under the curve between 1 and 3? The area under the curve between 1 and 3 is these 4 blocks, so that area is 4. Next, evaluating this guy. I actually will go through that one. So start off with right here, go ahead and record it down everything. Take the antiderivative of that. Remember the antiderivative of sine is negative cosine. The inside stays the same. And then because this 2 would pop out when you differentiate it because of chain rule, we have to undo that by multiplying by the reciprocal of this derivative, which is 1/2. And we're evaluating between pi over 2 and 0. All right, now let's start to plug those values in. Remember, we're doing top minus bottom, so plug in the top. So cosine of 2 times pi over 2 plus pi times 1/2. And minus, and then rewrite it, it's negative cosine of all that. Plug in, you get 1/2, or that bar. There's 2's cancel out, so really this is 2 pi here. Cosine of 2 pi is 1, times 1/2 is 1/2. Negative, we get negative 1/2. Over here, cosine at pi is negative 1, so it's negative 1/2. Well, these have already canceled out to be positive, so it's negative 1/2, negative 1/2. You'll get negative 1 there. All right, let's dive back into our content over here. Skip that, skip that, skip that. Binomial distribution. So the binomial distribution, we saw this a bit in the fall. We're going to do a little bit more with it here today. So had we been together, I would ask you guys to go to the boards and give this a shot. Here's what we're looking at. A basketball player makes 40% of their threes, which is a great shooting percentage for a game. Model the outcome of these 3 random shots. Okay, so first with a tree diagram. Remember a tree diagram, and I would encourage you guys, try and do these on your own before I show you everything. But our tree diagrams are going to look something like that. Yours are probably prettier than mine. Remember a make, so we'd have the probability of that happening is 0.4. And then maybe this is miss. Maybe this is M not is 0.6. That's the first shot. For the second shot, we can make or we can miss. And for the third shot, you can make or miss. So on each of these branches, there's an associated probability with that. And then to get the end outcome, we multiply all these together. So the probability of 3 makes is 0.4 cubed. The probability of a make, miss is 0.4, 0.4, and then 0.6. So 0.4 squared times 0.6. For the next one, this would be a make, a miss, and a make. So it would be 0.4, it should be squared times 0.6, and so forth. So then we could figure out what's the probability of getting 1, 2, 3, and so forth. If you're real careful with that, you'll get the distribution table. Mine's spread out a little bit like that. So the probability of 0 is that, probability of 1 there, 2 there, and let me just slide over a little bit so 3 can come on the screen and I can actually move this over. Okay, so there's your distribution table. The graph, that's a real simple spike graph. You'll just go up 0.216, go up almost double that, 0.432. Try and keep it all to scale. Okay, but then I also want to remind you guys of the shortcuts for these. Your calculator will do a lot of this for you if you know how to ask it. Let me bring this back over here. Sorry, that's a little bit dusty. This is actually my calculator from high school, which is crazy. All right, a couple ways to do this. First, remember in y equals, we can just put in the binom PDF. Remember the syntax is NPX, it's alphabetical. N, we have, in this case, our N is 3. Let me just put that over there. 3, our probability of success is 40%. And we wanted to tell us x's are unknown, so now I'm going to look at the table. And there we get those values. Okay, great. Let's keep going. So in general, for a binomial thing, so a binomial experiment, P is the probability of success for n independent random trials. will be conducted. R is the number of successes. So the question is the probability of it equaling some number of successes. Well, this is similar to what we looked at earlier in the year. Let me come back over here, guys. It's that same binomial distribution function. So the probability x equaling something is equal n choose r, n being the number of trials, r the number of things you want. This is the number of ways it can happen, the number of branches on the tree diagram that produce what you're looking for, multiplied by the how many successes you want to that power, how many successes there are, maybe there's 3. And this is the probability of it not happening, 1 minus p. If it was a 40% make, 60% chance of not make, multiplied by how many not makes there'd have to be. So that's that piece. Okay, does this apply to replacement situations? Does it apply to non-replacement situations? So let's say we have a bag of marbles. If we take out the marble and don't put it back in, does it still work? The answer is no. Why not? Because we've changed the probability of success. If you change the denominator, you've changed what's likely to happen, so your probability is changed. So this does not work. Now, if you put back in the marble every single time, well, your probability remains the same throughout, and so yes, this absolutely works. So make sure you're only applying this for replacement situations or things in which this probability is constant, like things where there's thousands of trials or many such that your probability is the same and you don't have to worry about it moving. Onward. A reminder as far as what your calculator, so the probability x equaling exactly something, that's your probability distribution function. That's the NPX on your, not NPX, that's our PDF on your calculator. And remember, if you want a cumulative distribution, that's when you want like the probability of x being less than or equal to 3. Well, that's CDF on your calculator. And again, you get to these here. You go second dist, and it's kind of hidden at the bottom actually. You have binom PDF and binom CDF there. Let's keep going. A bit of new notation that we're going to start seeing more and more of as we get deeper into statistics. So this reads x, the random variable x. This symbol means is distributed. So the random variable x is distributed binomial on the binomial distribution with n trials, and this is the probability of success. So real briefly, they could just say x is distributed on the binomial curve. We have, I don't know, 10 trials. The probability of success, whatever this is, generally is 0.3. Show the distribution. So that could give you that little information and us produce a distribution off that. All right, let's try an example here. All right, 72% of union members are in favor of a certain change to their contract. A sample of 5 is taken. Find the following. The probability that 3 members are in favor of this change. I'm going to use the calculator. I'm going to use this binom PDF here because I want to know an exact number. Whoops, I was in something. Let me go back in here. Binom PDF. NPX again. N is the number of trials. It's 5. Our probability here is 0.72. In this case, I want to know 3 people. So here's our probability that 3 of them are in favor of this. Next, the probability that at least 3 members are in favor of it. So at least 3 means 5 is okay, 4 is okay, and 3 is okay. Let me show you something on the document camera here again. So here I'm looking at this line right here. I'm looking at B. Let me move this over. Probability x is greater than or equal to 3. Remember, your calculator is not built for greater than or equal to. Your calculator is built for less than or equal to. So I have to translate this. If I want to include 3, 4, and 5, I'm going to do 1 minus what I want to take away or exclude. I want to exclude 2, 1, 0. So 1 minus 0, 1, 2 is the same thing as this. Practice that if that feels cloudy for you. Okay, so then in doing this, now this piece, that's going to be the CDF function. So let me go and find that in my calculator real quick. So doing that, 1 minus binom CDF, number of trials, success, and 2. And you should get the probability of that happening, 0.862. And finally, part C, the expected number of members in favor of this. Remember, expected is just the probability of something multiplied by the number of trials. If there's 72% of them and there's 5 people, we would expect 3.6 of them to be in favor of whatever this is. Okay, onward we go. To practice these ideas, there's 7 questions in our book that I think are worthwhile. Let me make this full screen so you can access those a little bit easier. There's those if you want to freeze it. That one if you want to freeze it. And there you go. Again, I hope you guys are doing well. I would much rather do this in person, but we can't. So I hope these work for you guys. Take care, everyone. I miss you all.